Dubro Suspicion Files.
So I want you to forget everything you think you know about the space race. Seriously, this isn't some black and white replay of the 1960s. This is something entirely new. It's happening right now. And honestly, the stakes are way, way higher. We're talking about a quiet, high-stakes conflict for what might be the most valuable real estate in our entire solar system. And that really is the question, isn't it? Let's get right into it. Why this one specific spot? I mean, the moon is huge. What makes the lunar South Pole so unbelievably critical that the world's biggest powers are in an all-out sprint to get there first? Well, people are calling this the Lunar Shadow War. And that name is perfect, because it's not just about planting a flag and getting some nice photos for prestige anymore. No, this is a dead serious strategic race for resources and for control. Control that will literally define our future beyond this planet. And you've got two main players. On one side, you have the United States leading its international partners with the Artemis program. And on the other side, a really formidable alliance between China and Russia, who are building something called the International Lunar Research Station, or the ILRS. And here's the kicker. Both of them have publicly aimed their rockets at the exact same tiny, valuable patches of lunar ground. So what is everybody fighting over? It's not just some cool-looking rocks or a nice view. We are talking about this unique, almost magical convergence of resources that makes this one spot the absolute key to unlocking the rest of the solar system. It all starts right here, in what are called permanently shadowed regions, or PSRs. You see, the moon has this very slight tilt on its axis, and because of that, the bottoms of certain craters right near the poles haven't seen a single ray of sunlight in literally billions of years. They are perfect cosmic cold traps. And when I say cold, it's hard to even wrap your head around it. Temperatures in these craters can drop to minus 250 degrees Celsius. I mean, that's colder than the surface of Pluto. This unbelievable cold instantly freezes and preserves anything that happens to fall in. And the most important thing it preserves is water ice. And we're not talking about a little bit of frost here. We're talking about a colossal amount of water. Current estimates suggest there could be over 600 billion kilograms of water ice just locked away in the soil. To give you some perspective, that's enough water to fill 240,000 Olympic-sized swimming pools. It's just a staggering amount. But that's only half the story. Here's where it gets truly amazing. Right next to these deep, dark, frozen craters, you have something called peaks of eternal light. These are the high rims of the very same craters. And because of that same lunar tilt, they're bathed in near constant sunlight. What does that mean? A perfect, endless source for solar power. So you see the geographic jackpot here, right? It's just incredible. You've got these massive reserves of frozen water, which you need for life support, for breathable air, for fuel, sitting right next to the endless solar energy you need to get it out and process it. Water and power side by side. Nowhere else offers that combination. It's the ultimate prize. Okay, so we've found water. Big deal, right? Well, let's break down why this frozen water becomes the absolute key to our future in space. This isn't just about giving astronauts something to drink. This is about creating an industrial base off-world. The whole process has a fancy name, In Situ Resource Utilization, or ISRU, but it's actually pretty straightforward. First, you've got to extract the ice from the soil, probably with heat. Then you capture that water vapor. It needs to be purified because the next step, electrolysis, splits the water molecule, and for that to work, the water has to be super pure. That split gives you hydrogen and oxygen. Finally, you cool those down until they become liquids, and boom, you have created high-grade rocket propellant. And that right there, that's the end game. If you can make rocket fuel on the moon, you've essentially created a cosmic gas station. Think about it. Missions to Mars would no longer have to lug all their fuel for the return trip all the way from Earth. That dramatically cuts the cost and complexity. The moon stops being just a destination. It becomes the launch pad to the rest of the solar system. Now, let's get back to the two teams. Because while both sides are racing for the same prize, they have totally different game plans for how to power their dreams. And this is where the Shadow War gets really, really interesting. Okay, so the Artemis program is basically all in on solar power. That makes sense, right? But it means they are geographically tied to those peaks of eternal light. They have to be there. The China-Russia ILRS, on the other hand, they're betting on nuclear power. And that completely changes the game. It makes them independent of sunlight, giving them a massive strategic edge. And just look at how this breaks down. You can really see the different philosophies here. The energy source for Artemis is solar arrays, but the ILRS is planning to land a 100-kilowatt nuclear reactor by 2035. That gives them the freedom to go anywhere, to set up shop in the deepest, darkest, most ice-rich parts of a crater, and to operate 24/7, even through the 2-week-long lunar night. You can see how this creates a huge vulnerability for the US-led effort. With the China-Russia alliance aiming to land a crew before 2030, the Artemis program is now in a desperate race against the clock. And frankly, it's facing some pretty serious challenges. And hey, you don't have to take my word for it. The US government's own watchdog, the GAO, has put out reports saying the Artemis schedule is overly ambitious. They basically said that by rushing, you actually reduce your chances of success. It's a huge warning sign. And the whole mission is counting on solving these massive technical problems that just aren't solved yet. The biggest one might be this thing called cryogenic orbital propellant transfer. It's basically refueling your lander in space. It's absolutely critical, and progress has been slow. Then you add in super complex software and the enormous problem of that abrasive, machine-killing lunar dust, and you start to see the scale of the risk here. But this is about so much more than just a race to mine ice. This is a race to establish the precedents, the norms, the unwritten and written laws that are going to govern how humanity operates out in the cosmos. And that brings us to this key idea, first mover advantage. Think about it. In a place with a lot of legal gray areas, like space, the first person to actually show up and start doing things, their way of doing things becomes the standard. It becomes the accepted practice. So whoever gets there first doesn't just get the ice, they get to write the rule book for everyone else who comes after. Now, the US is trying to write that rule book ahead of time with the Artemis Accords. It's a political agreement meant to get everyone on the same page. But what happens if the ILRS gets there first and just starts operating under a completely different set of rules? You could end up with 2 competing legal systems in space, which would be a mess for decades to come. And that really leaves us with the ultimate question. You've got Artemis facing some serious technical delays, and you've got the China-Russia alliance moving ahead with a really robust, flexible nuclear strategy. The race is on. And we have to remember, the winner here won't just claim a piece of the moon. They will set the course for our entire future as a multiplanetary species. So, who do you think will get there first?